This video will cover the inverse functions worksheets. We're going to cover questions 3, 5, 6, 8, 11, 13, 16, and 17. So let's start with number 3. We need to find the inverse of f of x equals 2x. So first off, let's replace f of x with y. Y equals 2x. Next up, we need to switch x and y. So we'll have x equals 2y. And then we need to solve for y to find our inverse. So divide by 2 to get y by itself. And you'll get y equals x divided by 2. Last step, replace y with the inverse notation f negative 1 of x equals x over 2. Now for number 5, we have f of x equals x minus 2 divided by 5. So we need to find the inverse of this. So first off, replace f of x with y. Y equals x minus 2 divided by 5. And then we switch x and y around, so we'll get x equals y minus 2 divided by 5. Now we solve for y. First step, we need to get rid of the 5 first. So multiply both sides by 5. That'll cancel the 5's out. So you'll have 5x equals y minus 2 divided by, we got rid of the 5. So we have 5x equals y minus 2. Now next step, we need to get y by itself. So we're going to add 2 to both sides. So you'll get y equals 5x plus 2. And then replace y with your inverse notation, f negative 1 of x equals 5x plus 2. Yay. Number 6. So we have f of x equals 3x plus 1. So go ahead and replace f of x with y equals 3x plus 1. Switch x and y around. You'll get x equals 3y plus 1. Now solve for y, meaning we need to subtract 1 from both sides. You'll get x minus 1 equals 3y. Last step to get y by itself, divide by 3. And you'll get y equals x minus 1 over 3. Now replace y with your inverse notation, f negative 1 of x equals x minus 1 over 3. Alright, number 8. Find the inverse of a coordinate pair. I hope you all remember this. Just switch x and y. So instead of negative 3, 1, it'll be 1, negative 3. And again, another easy one. Number 11. Find the inverse of a table. Just switch your x and your y column. So you'll have 3, 5, 7, 9, 1, 2, 3, 4. Flip it over. Number 13. Find the inverse of the graph and state whether the inverse is a function. So we have our sideways quadratic function. Let's go ahead and find 3 points on this quadratic function, the vertex, and 2 on the sides. Let's go ahead and say this point and this point. Those points are negative 5, 0, and negative 1, 2, and negative 1, negative 2. Find the inverse of those. So 0, negative 5, 2, negative 1, and negative 2, negative 1. And replot those. So 0, negative 5, 2, negative 1, negative 2, negative 1. And your new graph is right there. Now this does pass the vertical line test, so your inverse of this function is a function. Yay. But yes. Okay, number 14, really easy. Find 2 points. Number 16. Determine if the given functions are inverses of each other. Number 16, we have f of x equals square root of x minus 2 divided by 3. And we have f of negative 1 of x equals 3 times x squared plus 2. So are these inverses of each other? So from our notes, the composition of functions, we can go ahead and substitute in one of our functions in for x and solve. If it comes up with x, then they are inverses of each other. So let's go ahead and plug in our regular function into our inverse. So replace x with your function. So you'll get, let's go ahead and replace this with y. So we'll have y equals 3 parentheses, another parentheses for your function, square root of x minus 2 divided by 3 squared plus 2. So now we need to solve for x. Well, simplify, not solve for x, but just simplify. So let's go ahead and square the inside of our parentheses. So squaring the top will get rid of your square root. So you'll have y equals 3 x minus 2 divided by, now square the bottom. 3 squared is 9, and then plus 2. So now go ahead and distribute this 3 to the inside. You'll get y equals 3 x minus 2 divided by 9 plus 6. Now let's go ahead and simplify this fraction here. 3 divided by 9. How many times is this 3 going to 9? Goes into it 3 times. So actually, scratch that. Break up 9 into its multipliers. So 3 times 3 is 9. Now what happens with our fraction? What cancels? These 3's cancel. So we're left with y equals x minus 2 divided by 3 plus 6. Now, in no way is this going to simplify anymore. This is pretty much it. So we don't have x by itself. So this is not an inverse of each other. Okay, number 17. Check if these graphs are inverses of each other. So let's take this line here and find 2 points. So that point and this point. So that's going to be -4, -3. And that'll be 5, 0. Switch this around. We'll have -3, -4. And 0, 5. So plot those. -3, -4 is right here. And 0, 5 is right here. Are those 2 points on the given line? No, they're not, so this is not a function. Well, this is not a inverse of each other. Okay? So go ahead and do the rest of these by yourself. They're pretty simple, so don't freak out. I expect this to be done by tomorrow when I get back to school. So thanks for watching, and thanks again. Bye.